Let's now consider bar graphs, and this is where the height of the bar is going to equal the value of the dependent variable. So let's look at an example. Here we have a shirt inspector at a clothing factory, and they've categorized 500 defects as 67 missing button, 153 items had a bad seam, 258 improper size, and 22 a flaw in the fabric. We're going to construct a bar graph for the information. So here I've listed the defects, size, seam, button, fabric, and then the counts. So here our total count is 500. Now we could do a bar graph that lists the count, and that's actually what I have drawn here. And I've listed these in decreasing size. You don't have to list them in decreasing size. If you do list them in decreasing size, this is called a Pareto graph. When they're listed in that order. And then let's also look at the percentages. So that is the relative frequency of the count. So 258 divided by 500 is 0.516 if you do the calculator work there. 153 divided by the total 500 will give you 0.306. 67 divided by 500, 0.134. And then 22 divided by 500, 0.044. And these add up to 1.00. So what we could do is we could just scale the right-hand side here for percentages. So our 500 is going to be 100%. So this is going to be the count on the vertical here. And then over here, it's going to be the percent. So then 400 will be 80%. 300 out of 500, 60%. 200 out of the 500 total, 40%. And then 100 out of 500, 20%. So graph has this same structure and the same proportions. All we had to do was add the percentage scale on the right, and we can graph both the count and the relative frequency of the count. So we could ask you questions like, what was the percentage of the most common defect? So what percent for the most common defect? So the most common defect was an improper sizing. That's the highest bar here. The count was 258 and the percentage 0.516, which is 51.6%.